Hello guys and welcome to my channel. My name is Milos and I'm a creator of original maps which are regularly posted on Instagram and Twitter. I'm back with another tutorial and this time I really want to level up your GIS and data visualization skills with R by showing you how you can create effective inset graphs within a map. I created one of those maps in the past and I can tell you they're crisper, they offer more details and insights to your audiences. So in today's tutorial, we'll be accessing one of over 2,000 datasets from the Global Health Observatory of the World Health Organization using rgho package in R. Then we will use these data to create an inset graph within a map of Europe for the 2021 data. Without any further ado, let's roll. All right, we are back in R and we are ready to kick off our adventure by first of all installing the libraries we need and then loading them into our session. So the way we are going to do this is first of all we're going to define a list of libraries we need. So this is going to be a list of strings and we're going to start off with the first one, which is going to be the library that will communicate with the Global Health Observatory API. Luckily for us, there is such a library. It's called rgho, and it's going to give us access to over 100 indicators that exist in this Global Health Observatory. The second one is more an umbrella package, and it's called Tidyverse, where you have different data wrangling and data visualization tools. The most famous one is, of course, ggplot2, which we will use in this session to create a bar plot and then also a map next to it. The next one is the asset package, which we will use to load the shapefiles, and in our case it's going to be the shapefile of Europe. Then to actually create this shapefile of Europe, we're going to use GISCO R, which is a very convenient library for accessing GISCO. It's a global service that allows you to access a shapefile of any country or continent in the world. Then in order for us to create this inset bar plot within a map, we need to create this space in our ggplots. And to do that, you need a grid package. Grid package is very, very useful for that. And then last but not least, I use classInt package, as you have already learned, for creating nice legend breaks. Now that we have defined the libraries that we need, we want to check first of all with R what are the missing libraries and then tell R to install those missing libraries. So the next step is install missing libraries. Now the way we do that is we create installed libs object, and within this one we then check if any of the libraries that we define within the libs are they available. So the way we do that, we check the row names within installed.packages. That's all. All right, and then when R checks if these are installed, if they're not installed, we need to tell R if these are not installed, please install them for us. So we need to write an if statement here. So if any installed libs, equals false, then we need to open curly brackets and we need to tell R, please install them. So install.packages, that's the function, but we specifically want for those installed libs that are not in our libs array. And finally, we need to load the libraries that we just installed, or if we already had installed, we can just simply load them. The way to do that is applying to a list the function library in R, which is exactly used for that purpose. So we here use lapply, which means apply to a list something. So apply to the list libs, apply library function, and then only for characters. So character only equals true. All right, now that we have all of this, we're gonna run, and what's gonna happen next is for any libraries that are here, will install them if they're not installed, and they're just gonna load them into this session. So we run this, And there we go. The next thing is we can go into our first package that we just loaded, which is rgho, and use it to access the data. Our next step is to communicate with the GHO API and load the data set that we need using the rgho package. This package has several very useful functions, and one of them allows you to, first of all, search for the available dimensions in these data sets. So these dimensions include, for example, what are the available regions or countries, and finally, what are the available indicators. The way you can do this is by using the rgho get GHO values. And then here you need to pass dimension arguments. And using the uppercase letters, you need to specify what you need. So for example, let's return the available countries. This is gonna show us the truncated list of available countries. What is very important to note here that apart from country name, you will also see here ISO 3 code. It's important because this will help us later on merge this with the shapefile exactly using its ISO 3 code because it's persistent, so it doesn't change that often. As I said, you can also see what are the available regions. So you just specify region dimension, and then again here you will see that there are different continents and subcontinents. And finally, you can also check the available indicators on a global level, and for that you specify dimensions equals GHO. And then when you run this, again you get two columns. So one, which is called title, is simply the description of an indicator, and code is the actual code that we will use here to fetch the data into R. Now, when it comes to getting the indicators that we want, rgho has also a very convenient function which allows us to search for specific key terms that we provide to it. And this is how this is achieved. So it's achieved using search_values function. And here the first thing you need to do is specify the key that you're looking for. So I would like to search for infant mortality. And the second argument is you need to specify the dimension. If you don't specify the dimension, then this function is not going to know where you're searching for. As we said, there are more dimensions. It can also be region, for example, or a country. So in other words, you can also search here those terms. If you're looking for a specific country or a specific region or continent, you want to see how they are named here, you can also use this function for that. But again, you need to specify dimension. And as we said, indicators are stored in GHO dimension. Now, if you run this, what you will see here is we get actually two potential indicators. One is simply infant mortality rate, so deaths per 1,000 live births. And the other one is also infant mortality, but for children between their birth and 11 months of age, so basically before they turn their first year. So in this tutorial, we will be using the second indicator, and for that purpose, we need to take now this code and to copy it. And after that, we will pass this to another function which exists in rgho and load the data directly into R. We will retrieve the infant mortality data set again using rgho, but this time it's going to be get GHO data function. Within this one, the first and the most important argument to specify is code. In our case, we've already copied that code from the table, and pay attention here, it's very important that this is a string format, so it needs to be specified this way. Now, if we run this as is, we will get a time series data for every available year, country, and region. It's going to be huge. So we want to do some filtering, and this is done through the filter argument. Filter and then equals, and then you can provide a list of potential arguments. One of them you already know, so you can specify, for example, country. So you can take, for example, ISO 3 code. For Belgium, it's Bel. So if you want to go for Belgium, you can also specify filter by years. So it's year, let's say the last available one for the infant mortality data is 2021. So if you run this, it's going to give you just for Belgium for 2021. Unfortunately for us, this function does not support multiple countries for a single or multiple years. So we need to go here for all the available countries and regions for 2021, and then later on we can filter just for European countries. So for now we just remove this country equals Belgium, and then we can also create here an object which we're going to call like res, for example, a shorthand for results. And we're going to just run this. And finally, we're going to inspect this data frame that we just got. Let's inspect the first 6 rows. So we're going to run head res. All right. And once we run head res, we actually got the table. So the table has a lot of columns. Some of them we don't need. For example, the ID indicator code, or for example, the date and the year. We already know that we fetch only for 2021. But there are some things that are important for us. One of them is this numeric value. And as you can see, this is a mean point estimate value. There is also a low and high estimate values, which is very convenient for us, meaning that we don't need to simply create a box plot. We can also, for example, create an error bar. So very, very useful. And then another useful column that we need here is country, where ISO 3 codes are stored. And you can see some of them are NAs. That's because some of these values are actually for the regional level. And we want to filter those out. We only want to keep countries, and we want to only keep the specific countries. Finally, another important filter here is the sex, which can be female, male, or both sexes. Both sexes is denoted by BTSX, so we will be looking only at both sexes, but of course feel free to filter this in any other way. So in the next step, we will filter out only European countries, both sexes, and we're gonna also select only numeric value, low, high values, as well as the country field. Now, you might be wondering, how do we filter European countries, given the fact that in this newly retrieved data frame, we only have the column for countries, but not also for the continent? Well, I'm going to share a trick with you. We will actually, first of all, fetch a shapefile of Europe through rgho, and in that shapefile, we already have a column with ISO 3 codes. So we will then just create a list of unique ISO 3 codes for European countries, and then use that to filter the data frame. So let's start off with, first of all, creating a Europe SF object, which is going to be a shapefile based on rgho get countries. Now, within this function, we need to specify 2 things. First of all is resolution. So how crisp is this going to be? What is the level of detail? Let's go for 3. 1 is the highest level of detail, and 50 I think is the lowest. And then for region, we can also specify Europe. All right. Over here, what you can also do, if you're working with maybe some other continents, you can also specify other names. For example, Americas, that's for South and North America. Asia is for Asia. Africa is for Africa. Australia. So you get the point. Now, once we get this, we need to create a list of unique ISO 3 codes. Well, first of all, let's run this code. And once we run this code, I want to show you what actually this has. So let me just expand this a bit, and then let's expand the Europe SF. As you can see, what we have here is the following. So we have this ISO 3 code, which you're going to use to actually create a list of ISO 3 codes for European countries. And then based on that list, we will filter our data frame. So pretty useful. So let's do that. So Europe list equals 2. And then what we need to do is we need to declare that it's also list. And then we use the function from base R, which is called unique. And then with this unique, we take Europe SF and we take ISO 3 codes from it. That's basically it. All right, so let's now run this. And let's just quickly inspect the list of European countries. So there are 50 according to this list. And this is the list of these countries. So what we're going to do next is use this list to filter the data frame. So we're going to create a new one, which is going to be Europe DF, which is a shorthand for data frame. And it's going to be based on this res object that we previously created. So this is this data frame with information on infant mortality for all the countries around the world for 2021. And then we're going to use dplyr for data wrangling from the tidyverse packages. And from this one, we're going to use filter option. And then within this filter option, we are going to specify the following. So we want country to be available in this Europe list that we created. So this chunk will retrieve only countries that exist in the Europe list. Now we also said that we want to filter the sex. So we want to get the data for both sexes. So we can do the following thing, the same thing. So from dplyr, we just take filter, and then within filter, we say sex equals to the cell BTSX. So this is the acronym for both sexes. And then we finally said that we don't need all those columns. So we can just select a few of those that we need for creating those plots. Again, dplyr and a function selects. And then from this one, as we said, what we need is the following. We need country. Then we need numeric value. Numeric value, if you remember, that's the mean point value. And then we need low and high. These two, low and high, these are optional. So if you don't want to create error bar, then you can just go for country numeric value. If you're working with some other data frame, so you're not really using this package to communicate with the rgho API, what you really necessarily need is either ISO or ISO 3 code column, and then the value column, and that's it. So for example, if you go back to one of the previous tutorials I made where we used WB stats to get data frame from World Bank database, what you essentially need from that one is a column which would be ISO 2 or ISO 3 code, and then the value from that database. All right. Now that we have this, what we just need to do is finally run this whole thing. And then we can simply just inspect this Europe DF file. Nothing special, so we have country, value, low and high value. All right, this is all that we need to do about data wrangling when it comes to this specific data set coming from the World Health Organization, Global Health Observatory. The next step is to create our map in ggplot2. In order for us to be able to create a map in ggplot2, we first need to merge the Europe shapefile together with Europe data frame with infant mortality rates. And we will do that using dplyr function left join. For those of you who are not familiar with left join, it comes from SQL, and it basically means the object on the left hand side, we take all the features from it and all other features that overlap between the left and the right hand side object. Let me show you how this looks in practice. We're going to create a function which is for us going to do all these things, and we're going to call this function spatial join. And in R, we define this function in the following way. We say this is function, and then we open this curly brackets, and within this we can now declare the objects and make the necessary transformations. So let's, for example, create an object which is going to be called Europe joined. And the left-hand side object is always the first one that you define for joining. So in our case, we want Europe SF to be this first object because we want the resulting object from this function to be again a shapefile. And then from dplyr, we call left join. And then within this one, on the right hand side, we will have the Europe data frame. So Europe_df. Now we also need to specify the column which is going to be used to join these two objects. But in our case, we have one obstacle, and that is the left-hand side object, column name, is called ISO3 code. But the one on the right-hand side, it's called country. So the way to overcome this obstacle is simply to declare it this way. You create a list, and then within this list, you first specify the column name from the left-hand side object, so that's Europe SF, and then equals to the same column, well, the column that signifies the same thing, which is in this case is ISO3 code, from the right-hand side objects. So in our case, that's country. Once we are done with this, we can also get rid of some of the NA values, which will for sure be generated. So there are some microstates, such as, for example, San Marino, Liechtenstein, Gibraltar. And for those, most likely there won't be any values. So we want to get rid of these microstates since they don't have any values. So to do that, you just simply declare here drop NA within the pipe. One also thing that we want to do here is we want to declare this object once more to be a shapefile. Just to make sure that we do that, we can use SF, and then there is a function st as SF, which is going to put it into a SF format. And then finally, we can also select only those columns that we actually need. And again, as we did in the case of the data frame, we use dplyr select function. And one of the things that we want from the shapefile itself is the name English. So this is going to be the full name of the country in English. The other thing we want to have is that value, so numeric value. So this is the mean point estimate of the infant mortality rates for every country, and we can also grab low and high values. All right, and then finally what we can do here is, since this is the end of the code, we can simply return the object that we created. So that's going to be Europe joined. And then finally, we can just run this function and create a Europe join object outside of this function, like this. And we can then run this code. And once we run, I want to just show you the actual output of this Europe join, what we actually got here. Here it is. So we got, as we wanted, a shapefile in the form of a simple feature or SF object with the WGS84 coordinate reference system, and it has a couple of columns, name English, so this is the full country name, followed by mean point estimate for the infant mortality rate, low and high values, and finally the polygon for each country. Now that we have this, we can move on to creating legend breaks for our map, declaring the palettes, and then finally creating the map. All right, for legend breaks, what I really like to do is create a discrete legend breaks, which will have keys where every key is going to be values from 2, starting from the first value, then going with every next value and ending with the last value of the legend break. Now, there are different ways or different methods, to be more precise, for creating your legend breaks. I like to use natural intervals from the class.int package, and in specific, I like to go for the Jenks natural intervals, or also known as Jenks optimization method, which were created in the 1970s by a geographer Edwin Jenks and are widely used for data visualization and mapping. In short, Jenks natural intervals minimize the variance within each interval while maximizing the variance between intervals. And the The advantage of this method is that it offers distinct and meaningful groupings based on your specific data values. So let's get down to it. The first thing is we are going to create object ni, which is a shorthand for natural intervals, and we're going to call class int object and then its function class intervals. Within this one, we are going to create natural intervals based on Europe joined and a numeric value column. Then for the number of breaks that we want to create, I usually opt for a number between 6 and 8, so I'm gonna go here for 6. But even though I defined here 6, just remember that it can happen that this function returns fewer or more than 6. It's going to depend, of course, on your own data points. And then finally, for the style, we're gonna go for James. And then what you need to also specify here as a last step is that you would like the output of this to be breaks. Otherwise, if you don't specify this, it's going to throw an error. All right, now that we have these labels, or actually better say breaks, we want to create labels. Labels are going to be for now an empty list, but we want to populate this empty list in the following way. We want the first and every next value. We want those values to be turned into a keys so that we have from to value ending with the maximum value. All right. This is how we do it. So we need to iterate here through the ni object. So for I in 1 to the length of this ni object. And then what we do here is we just append this labels object in the following way. We append it so that we paste every value, so the starting value, NIE value, add dash, and then every next NI value. So I plus 1. So this is going to create exactly those legend keys. So every value, dash, and then every following value. All right. Now, one thing that I also like to do here is round the decimal numbers. And this is what I'm also going to do here. So I'm going to round this to 0. So I don't want actually any decimal values. And I'm going to do that also for every following values. So 2 values. All right. Now that we have defined this, so we have the legend breaks, we have the labels. Now we need to use these labels and carve out a new column, which is going to be this categorical value. And it's going to be associated with our infant mortality rate values. So for every country, we will have its own legend key. This is how we do it. So we again go back to Europe joined and we create a new column, which is going to be called cat, which is the shorthand for category. And for that, we use cuts function from base R, where we need to specify what actually we are cutting. So we are going to cut the numeric value column, and for cutting we're going to use ni breaks that we previously defined, and we're going to attach or glue to each of these breaks those labels that we also created. And then finally we're just going to say that we also want to include even the lowest value. All right, there is one thing here that we maybe forgot or we omitted or we didn't actually include, but it's quite important. And this is the following. So what we will get with these labels here, we're gonna get, starting from the first value, and then every next value, we're gonna add dash next to it. But what happens if our starting value is the last value? Then what happens here is that you will have the last value, so the maximum value, dash, and then here it's going to be NA, or it's going to just repeat that maximum value. So we cannot allow that. We need, in other words, we need to get rid of that last value. So we're gonna update then this labels object, and we're just gonna put labels from 1 to the length of labels, and then discard the last one, so -1. All right, rather than running all of this, I would like to run one by one, and then I want to show you what actually we have here. Right? So first thing, let's just simply run this one, and then also let's increase this a bit, and let's inspect the breaks. So these are the original breaks. They range from 0.9 to 12 infant mortality rates. All right, and as you can see, we also have, let me just return this back. So we have 1, 2, 3. So we have seven values. So again, this is what I was saying. Even though we specify 6, we got 7 breaks, because it does depend on our data points, whether it can return 6 values or it thinks that it's better to go with 7. Now let's do labels. Let's do labels here, and let's also iterate through them. And now I'm just gonna inspect these labels, and I'm gonna show you what I was saying about the last value. So here it is. You see, the last value is 12 to NA. It's exactly because after the maximum value, there is no other maximum value. So this is why we need to get rid of this one. And we're gonna get rid of that one just by running this code. And after running, let's inspect again. Labels, and as you can see, we don't have this 12 to NA. So we are left with six categories here. And then the final one is simply to carve out a categorical column, and we can also inspect the levels of this new categorical column like this. And as you can see here, it does match, so we have 6 legend keys. For those of you who are not familiar with this website, this is a web interface for Chroma JavaScript library, which helps with mixing colors and creating colorblind friendly palettes. I'm a frequent visitor of this website, which you may have learned from my previous tutorials, and the reason for that is that I can easily create new color palettes and that are also colorblind friendly. So why is it so important that our colors are colorblind friendly? That's because a certain proportion of population cannot distinguish among certain colors. So for us, it's really important, for us who are not colorblind, to create palettes that others can also understand. And this website helps you exactly with that. What you will see on the left-hand side from that circle from my image is a hex code of colors that I created. So you should, if you want to use this interface for creating colors, you can just pass this, but it needs to be in a hex code, and they can or they don't need to be distinguished among each other by a comma. Then above my picture, you will see a number of colors that I chose. We need only 6, but if you operate with a higher number, you can also increase here. So I'm just gonna return to 6. And then on the right bottom sides, you will see also a message says this palette is colorblind and safe. This is very important. So then you can click also here. There's 3 types of colorblinds to see actually how colorblind people see certain palette and what are the conflicts. And then if you scroll down, you will also see different things like, for example, level of lightness, saturation, and hue. And the most important thing here is that you can copy this chunk of the code. So those are the 6 values that ChromaJS has created for us. And then you can paste it into ggplot2 and create maps. This is also a ggplot friendly format. So it's very convenient that we can directly put it there. All right, guys, so the next step is to create a bounding box of Europe, which will help us limit the view on the Europe as a continent. First question you might ask is, what is bounding box? So I already prepared one of the tutorials in the past which shows you exactly, what bounding boxes mean, how you can create them in R, and how we actually use them. And it's also explained on this case of Europe. But in this specific context, we're using bounding box because we want to limit the view only to the European continent. That means getting rid of the part which is the Asian part of Russia, and simply showing European countries to a certain extent. Now the second question is, how do we actually go about this? Well, here is how we go about this. We first of all need to define our base coordinates reference system, which is going to be the standard WGS84. And then for Europe specifically, I define this Lambert projection, which we're going to use. Now, if you are using this tutorial to, let's say, create an Inset graph over a map or within a map or some other continent, let's say Latin America or Africa, you don't need to use this coordinate reference system because this is something that is native to Europe. And it's highly recommended that you use this for Europe because it well approximates its coordinate points. It's more precise than this WGS84 and looks better when you create a map. So this is something to keep in mind. So if you are using this tutorial to create a map of another continent, you can just stick to this one here. And also you can skip this part where I create the bounding box. So you don't need the bounding box for other continents. This is only because we are working with European continent, which is specific. So we need to carve out a space. We need to limit the view of Europe itself. So let's get down to business. We're going to create a new function, which is going to be called getBbox. And then within this function, we are going to do several things. First of all, of course, we're going to define the coordinates. Well, we're going to create a bounding box based on some coordinates that I actually pre-selected. So let's create an object called BP, which is going to be a shorthand for a bounding box. And then let's create a list of simple features where we're going to put those coordinates that we need for the bounding box. The way you create a list of simple features is by using this st_sfc. And then within this list, we want to use this list of coordinates to turn our bounding box into a polygon. So we need to work with polygons here. So this is done by using sfst polygon. This is how you turn, in this case, a list of coordinates you turn into a polygon. And then here, what you need to define, you need to first of all define the first list. The first list are going to be the series of x or longitude coordinates. All right, so we are starting with a minimum value, which is going to be minus 10.6. We use this one so that we can actually also get Iceland in our view. And then we don't go that much farther east. We choose 33.0 for the maximum. And then you again define the maximum within this list. And then again minimum. And then you close off this list with another measure for minimum. So this is how it's done. Then the second list is the list of latitude or y values. So this is basically south to north. What is going to be the scope of that? So for the south, which is the lowest value of the latitude, we choose something where we can capture the Crete islands of Greece, but not North Africa. So that would be 32.5, let's say like that. Then you again write the minimum value. Then you write the maximum value where we're going to capture Iceland and Scandinavia in the north. So it would be something like 71.005 or 70, something like that. And then again, you declare within this list the maximum latitude value, and then you wrap up this with the minimum latitude value, which is going to be 32.5. All right, now that we define this list, what is very, very important here is to declare the coordinate reference system here, because if we go just by this, we're going to create a polygon, but R is not going to know what these numbers mean. It's going to just create the polygons with some numbers, so they're not going to be referenced in space. What we actually need to do next is we need to declare CRS here. So CRS equals, and then we will choose the WGS4, so long lat CRS, because these numbers refer actually to that format. So we cannot right away turn it into a Lambert projection. We first need to go with this. We could if we knew how these numbers look like in the Lambert projection, but I honestly don't know, because most sites, they operate, including Google Maps or OpenStreetMaps, they operate with these WGS84 coordinates. So this is how it is currently. All right, so what we have here is this and the polygon, and we see that something is missing here. Well, what is missing is that after the polygon, we need to say that this is a list, and then we need to open brackets, and then we need to say here that we want to bind them together, these coordinates into a single list. This is how it looks like, and then here at the end, we will then have actually 2 more. So this is 3. We have now everything, and we can now close off this one. All right, so we have this, we open the list, we open also this C bind, and then we close actually here, and everything is closed now. All right. Now that we have this, we can actually what we can do next, we can transform this into a Lambert projection. This is done through SF package and its function sttransform. And over here, we just say CRS is going to be CRS Lambert, which is already predefined. And finally, in order for this to be used in ggplot so that we can actually limit the view to a certain bounding box, we need to turn this into proper bounding box. For now, this is simply a polygon. So the way you turn that is using again SF package and its function stbbox. All right, bbox, just like this. And then at the end, you simply within this function you return bounding box, and after we do this, we can just call this function, which is called gets bbox. All right, so what we are going to do now, we're just going to run this whole thing, and then I will show you actually how this bounding box looks like, why we created, and then how we're going to plug into ggplot. So let's run this and then see what we get. All right, guys, I'm super excited about creating our map in ggplot2. And before we start, I simply defined here the colors that we previously created in Chroma.js. All right, let's get down to it. Map equals to, and we call ggplot as the first step. And then we add more things to it. And one of them is our first and only layer that we're gonna use, which is filling the polygons with colors according to the category that we carved out of the infant's mortality rate. And because this object is an SF object, we need to use geon_sf function in ggplot2 to define our arguments. And the first one is data. Data itself is, if you remember, Europe joined. Now, because this one is the main layer, we need to define also the main aesthetics, which is handled by AES argument in ggplot2. Our one and only aesthetics is to fill the polygons. So fill equals to, and filling with the cat arguments. Everything else that we can add now to this GeoMSF is going to be a constant, and constants are placed outside of these AES brackets. So one of the things that I would really like to specify here as a constant is are the national boundaries. So this would be the color argument for the color of the national boundaries. Because this color palette is a bit darker, I would like to keep the national boundaries white as well as the background. So color equals white. And then I would also like to define the thickness of these national boundaries, which is handled by size. And I like to keep them a bit thinner, so somewhere around 0. So let's say 0.125, something like that. All right, now that we defined our main layer, we can go ahead and customize our plots. So one of the things that we want to customize is the coordinates reference system. This is handled by coords_sf. Coord_sf. Now, if you are working, for example, on, let's say, a map of Africa or, Latin America, what you need to do here, if you want to specify coordinates reference system specifically for that continent, you're going to go ahead like this, CRS equals, and then, for example, we already have CRS long lat, so you can do this. But because we are working on the map of Europe, we're going to do and go for CRS Lambert. And not only that, but we are also going to use that bounding box that we created, and we're going to use it to place the limits on the view of our plots. So we're going to do like this. First, we're going to define longitude limits, which is handled by xlim. And then we're going to create latitude limits, which is handled by ylim. Within the longitude limits, as well as the latitude limits, you need to specify here a list of two values. One of the values, or both of the values, actually come from this object pp, and one of them is the minimum x value, so xmin, and the other one also comes from bb, and it's maximum x value. Now you do this same thing for the y as well. You just change here y to y min and y max. And that's about it when it comes to coordinates. We can then go ahead and customize other things, like, for example, the colors for our polygons, as well as, for example, legend title. The way you customize colors for your plots is through scale, fill, manual. Now, I want to explain two things here. If, for example, over here in the aesthetics, you had color, then you would have used scale color manual. So, in other words, the argument in the aesthetic, whether it's fill, color, size, or whatever, is going to define also what you put here. It's going to be scale something, something. The second thing I want to clarify is this variable, cat, is actually categorical. It's a discrete variable. Whenever you are defining color palettes in ggplot2 for a discrete scale, you need to use manual here. If you had a continuous, then you would say here scale fill continuous. All right, that's about it. Second thing you can do here, as I said, is you can define the title name. And let's say we're going to define as deaths per 1K live births, which is almost exactly as what this measure means. It's also only for those deaths that occur between 0 and 11 months age. But that's fine. And then the second thing is values. Values here refer to color values, and we already defined them as cols, so we can just go ahead and do that. Now that we are done here with the colors, we can also define the legend outlook, and this is handled by guides. Now, very important thing, guides are also related to this aesthetics. So when you are defining guides, you're defining guides for a specific element in the aesthetics. In our case, it's fill. So fill equals to, and then you need to specify guide legends, which means that you are defining specific legend features only for this fill argument. And here you can specify several things. One of them is, for example, what is going to be, the direction of your legend? Is it going to be horizontal or vertical? Well, I say that in our case, I would like it to be horizontal. Then if it's a horizontal one, I would like it to be thin and wide. This is managed by key heights using unit arguments, and then within this one you say, for example, I want it to be thin as 1.5 millimeters. Of course, you can make it thicker, and of course you can also change these units. They don't need to be millimeters, they can be also centimeters or inches. For centimeters it's cm, for inches in. Similarly, you can also define the width here, and as I previously have said, I would like it to be wide, so let's say 10 times wider than this. Another thing that you can also specify here is the legend title and legend labels position, relative, of course, to this legend itself, legend keys themselves. So, for example, title.position equals to, and then I would like the title to be above those legend keys. And in ggplot2, if something is above, then you use top argument. While for the label position, I want the labels to be actually below. In ggplot2, if you're specifying below, you need to use bottom argument. There are other things you can also specify within this guide legend, and one of them is the horizontal and vertical justification. While we are happy with the vertical justification for the horizontal one, I would like the title to be somewhere in the middle, as well as the labels. So this is how it works with the values such as, for example, title.hjust, which is used for title horizontal justification. You should specify here a number which ranges from 0 to 1. 0 means left justified, 0.5 means that it's in the middle, and 1 means that it's a right justified. So because I want it to be in the middle title, I'm gonna put here 0.5. And same goes for label.hjust. It's also gonna be in the middle, so 0.5. There are other things that we can specify. One of them is how many rows or columns my legend is gonna have. Of course, because it's a horizontal one, we're gonna have just a single row. So n row equals to 1. You can also specify other things, but I think for this one, it's going to be more or less sufficient. One last thing though is, I would like my keys to be as close to each other as possible because it's a horizontal one. So I'm going to use by row argument and set it to true. If, however, you're creating a vertical legend, you should perhaps consider putting this to false so that there is some space among your legend keys. The next thing that we can customize here is if we want certain, let's say, title or caption, and this is handled by labs. Title, for example, here we can specify as infant mortality in 2021. We can also specify a caption. Within the caption, you can, for example, put the name of the author of this plot, but also data source. And the data source in our case is WHO, Global Health Observatory. Of course, it's also worth checking if this credit is sufficient or you need to put something else if you go to the website of the Global Health Observatory. There are some things that you can also leave empty, for example, X and Y titles, just like this. So you just define empty strings. And we can finally then move on to the theme, which is going to be how our background of the plot is going to look like. I like it to keep it minimal, so I want to discard all those lines, reticule lines from the plots. I want to prune them from the plots, so I use then theme_void for that. But because we have here title, caption, as well as legend, and we would like to really customize how they look like, their size and their position, then we also need to use a more general argument theme. And within this theme, we can then define what we actually want. One of them, as I said, it's legend.position, which can be descriptive in a sense top, bottom, left, or right, but you can also provide specific numbers. So if I, for example, want the legend to be in the middle, I would go for the X value of 0.45. But if I want it to be below the map, I need to choose something closer to 0 and maybe even a bit negative. So something like 0.01. Within theme, you can also specify, as I said, your title. So this is handled by plot style. But in this case, you need to tell the ggplot2 what actually plot title is. It is text, so you need to say this is element_text. And only then within brackets you can then specify the features of your plot title. One of them is size. Let's say, for example, that I want a bit bigger title. I want to go for 18 size. Let's say for the color, I want to grab a color from that calls object that we created, I want to grab the sixth, the last one, which is going to be that dark purple one, which I would say corresponds also with the sinister theme of infant mortality rate. You can also specify horizontal and vertical justification. When it comes to horizontal justification, I would like to push this title towards the right-hand side, because I do want to create that inset bar plot on the left side. So I want to push it as right as possible so it does not overlap with that bar plot. And you can also do vertical justification, which is handled by this vjust argument. And in our case, this actually measures how is it going to be positioned relative to the north of the map. So is it going to go more northwards or southwards closer to the map? If you want to go more kind of northwards, so away from the map, you should specify some kind of positive value. And if you want it to be closer to the map, then it's a negative. I want somewhere, a bit above the map, because I don't want to end up in a situation where my plot tile actually overlaps with the map. So I'm going to go for this. Because we have caption, we can also specify caption in a similar way with the plot title. It's going to be plot.caption. But over here, I want something that is a bit smaller. So let's say 9. And I also want something that is more kind of a light gray. So it doesn't really, it doesn't really affect your vision. It's like put more emphasis on a legend, in other words. And then for this one, I also want it to be somewhere in the middle. But because caption comes by nature just below the legend here, so it's on the bottom, I want to make sure that our caption is actually way below the legend. So it needs to be more southwards, which means we should specify here a negative value for vjust. Let's say -3. All right, now that we defined some of the basic theme features, we are ready to do the final, but I would say the most crucial part in this plot, which is creating some blank space for that inset bar plots on the left side. To do that in ggplot2, you can use a very convenient argument, which I used actually before in some of the previous tutorials, and it's called plots margin. Within this argument, what you can do is you can specify whether you want to shrink or expand or keep the same the space around your margins. And the way you go about plot margin is you use, first of all, the unit argument. And then within the unit argument, you specify 4 values for each of the sides of the plot. So, for example, for the top one, we're going to use t, and we're going to say that t, we want to shrink it, so we need to use negative values for that. And for expanding, use positive values. If you don't want any change, you just use 0. So for the top, we want to shrink it a bit, let's say -4. Then for the bottom, we will also shrink it by -4. But then the right-hand side, which is actually east, which we don't want to touch, we're just going to declare as 0. And finally, the left-hand side, where we want to create that extra blank space, we're going to expand it. So we're going to choose a positive value and a bit higher value, let's say 10. And finally, we wrap all this up by specifying the type of units that we want to have here. And in our case, the unit that we want to have are lines, but it can also be millimeters, centimeters, and inches. Now that we have defined our plots, we can simply run everything. And after we run, we can also print this map and see what we got. All right, here is the map that we just created. And you can see several things. First of all, we applied the color that we wanted. This color is reflected in the legend. Every legend key is very close to each other. There are also numbers showing the values for deaths per 1K live births. There's also a caption, which is not so much visible. It's just below the legend, which indicates the data source. What we also see is that the map is actually cut off somewhere in the east, so we don't show the entire Russia, which also belongs to Asia. I think that we cut a bit more, so we actually cut off part of Ukraine, but we can fix that one. And the second thing that I would also like to fix is the title is not completely visible. So let's go back to the drawing board and let's fix these two things and then check if everything is as we want it. Let's fix those two problems that we encountered when we plotted that map. The first one related to the bounding box and how much we limit the view. So we limited so much the view that part of Ukraine was cut off, even though the whole country is in Europe. So what we can do here is to increase the limits of our x-axis. So instead of 33, we can increase by a few degrees, let's say 36. So that's one of the things, and then we can rerun this function. And then the next problem was with the title, if you remember. So title was also cut off, and that's because we pushed it to the right side completely. Now I would like to perhaps return it back to the middle. So we're just gonna go here and change this, and then we can run this whole thing also again. All right, now that we have this, we can go ahead and see how everything looks like, and then if we're happy, we can move on to laying the foundation for the barplot. As you see, we fixed both issues. First of all, Ukraine is finally whole, and the second thing is that the title now is clearly visible. Next thing is to move on and start working on the data frame for the barplot and eventually creating the barplot itself. Before we can move on to create the barplot with the help of ggplot2, we first need to lay the foundation for our barplot, which means two things. First, we need to transform that Europe joined simple features object into a data frame, where we're gonna just select three columns that we need, basically country name, the category, and the numeric value. And then we want to also shorten some of very, very long names so that our barplot can actually fit into that inset map. It does not overlap the map itself. The second step will be then ordering those numeric values in descending order. Let's get down to the business. So the first thing is to create a function which is going to be called getBarplotDF. And then within this function, the first thing is to create, let's say, infant mortality DF. That's how we are going to call the data frame that we're going to create. And the reason why we are creating this data frame is that if you want to create a bar plot, a line plot, any other kind of a chart which is not a map, you need to have a data frame object. You cannot work with SF object. So the first thing is to take this Europe join object and simply in a pipe drop the geometry field, which is automatically going to create then a data frame. So it's a very convenient thing in transforming SF object into data frames, which is done through SF library and st drop geometry in specific. So this first part will handle that. Now, as I said, we want to select only a few fields. In specific, we want to select three fields. One of them is the name of the country, so that's name English. Another one is that numeric value, which is indicating the infant mortality rate. And then the final one is that category value, so cat. So we'll be using this country names to kind of as labels to show them on the bar plot. Numeric value we will also show them, but we will also use this one to organize in descending order the values, and then cat we will use to fill those values that we previously defined. We are not done here because, as I said, there are at least 4 countries with very long names. So if we keep those long names, eventually the bar plot will be too big, and when we inset within a map, it's going to overlap the map and it's going to create a mess. So to avoid this mess, we can use dplyer's function mutate to actually modify our column name English. Now, I don't want to create a new column. There is no need for that. So what I'm just going to do here is I'm going to use a replace function. So I'm going to replace certain values from name English. And to find what these values are, I'm going to use string R library from tidyverse and specifically str detect option. Now I want to detect again within this name English. And now what is the country that I want to detect? Well, one with a very long name in Europe is Bosnia and Herzegovina. So what I do want to do now, after I detect this one, I want to replace it with a shorter version. And that's going to be ISO 3 code for Bosnia and Herzegovina, BIH or BIH. Now, a very good practice is not what I'm going to do next, which is kind of just repeat these 3 more times and replace values. But I just want to quickly show you, what are the other countries that needs to be shortened if you are going to create this map of Europe with this inset bar plot. If you don't have any countries whose names should be shortened, you simply can ignore this part. You don't need to include it. And also, I would recommend that if you, like me now, apply this to more countries, that you don't copy and paste code like I will do now. You can simply create a function, or you can just apply this function to a list of these values of these countries with long names and then execute that. But for now, we're just going to do this very boring and not a very good way. The next country is Russian Federation, which we're going to shorten just to Russia. And then there is another country, number 3, which is North Macedonia. So North Macedonia, we will shorten this one to n.Macedonia. And then finally, the last country is United Kingdom, which we are going to shorten to UK. So now that we are done here with the data wrangling, one last part is to simply return this object, which we just created, infant mortality df, and then outside of this function we're going to create the object under the same name by calling this function get barplots df. So now I'm just going to run this, and after run I'm going to show you what is the actual outputs of this infant mortality df. So here it is. As you can see, we have 3 columns that we selected beforehand. So the name of the country, numeric value, and then the category that we assigned to. What I don't think is currently, useful here is the way this is ordered. It's ordered in alphabetical order, but we want for our bar plots to be ordered in descending order. So we can do the ordering right here. We can still work on this infant mortality df. We are not going to create any new object, so we're just going to modify the existing one. We open brackets like this, and then within this, because we want it to be in descending order, we put minus. If we want in ascending, we don't put anything. And then we call again this infant mortality df, and in specific we call the numeric value. And now for this to work, what we also need to do here is we need to say order. Order is from base R function, which actually, as the name suggests, sorts the values of a certain column in a data frame. And to let it know that it's a column, we need to put comma here for it to work. So if we now run this, and I'm just going to expand the terminal a bit, and then if we also open this, what we're going to see is that the infant mortality rates are now in descending order, starting with Moldova, which has the highest, Albania, Ukraine, and so on, up to the lowest one, which is Monaco. So this is how you order. Now we can move on to creating the actual bar plots. All right, guys, let's start by creating a bar plot using ggplot2 as well as the newly created infant mortality rate data frame. We first define object as B, which is a shorthand for bar plots, and then we call ggplots. So in this tutorial, one of the main layers we're going to create relating to bar plots is the one we fill them with values according to the legend breaks and colors that we defined. So we can do it right away here, because the way ggplot2 works is it's going to first check this ggplot and see if the layer is defined here, and then it's going to grab those arguments and produce a plot. If it's not, then it's going to go into a geom, in this case geom bar. So let's first define here in that case. So infant mortality df, that's going to be the main one, and then we need to define aesthetics, and one of them is fill. So we're going to fill it with get, but when we're creating bar plots, we also need to provide two more values to the aesthetics field, and one of them is the x value. So here we actually need to order again those numeric value columns, and that's because in ggplot2, whatever you did in terms of data wrangling before that, it's gonna be kind of rendered obsolete. So you need to do it again, unfortunately. So this time we need to use a reorder function within ggplot2, which actually allows you to sort certain variables, categorical value variables, by certain continuous variables. So here on the x-axis, we want to use country names, but we would like to sort them by their numeric value. Simple as that. And then finally, within this aesthetics field, we're going to define also y value, and for the y value, it's going to be numeric values. So the way this is organized currently is the following. We have x-axis, we have those country names, and then upward going spikes are going to be this numeric values. All right, so we define this first parts, and now what we can do next is we can now kind of specify more some other things, such as, for example, the bar plot themselves. Now, one thing that is very important when creating, bar plot, line plot, or wherever, you need to define geom so that ggplot2 knows what this applies to, because currently as is, this can be, also a foundation for a line plot or a dot plot or any other plot. So we need here to specify geom bar and tell explicitly to ggplot2 that yes, we are creating a bar plot. Another thing within geom bar that you need to specify is how these bars are going to be created. And of course, one of the possible options is that sum up everything. But in our case, we want to specify that bars are going to be created based on this numeric value y that we here did. So that's why for stat, you need to put identity option. Now, once we have this, we are ready to move on and actually add some more text options. So we would like to annotate these bar plots by showing the infant mortality rate values within them. And we would furthermore like to specify these values because we have darker colors for higher values. We would like those annotations to be a bit lighter, and vice versa for lower values, which are also lighter. We would like also that infant mortality rate annotation to be more visible, so to be in contrast darker. We can achieve all these things using geom text, and geom text is the integral part of ggplot2, so we don't need to do much here. But as we said now, we need to do some kind of a conditioning or subsetting of our data. And this is because one part of the data is going to have higher values. So let's say for those values that are 4 or above, we're going to create labels that are white. So let's subset the data, infant mortality df, and then we specify that for the numeric value, we want those values that are higher than or equal to 4. All right, now we specify another aesthetics, and this time for the text, which is handled by the label argument. For the text, we want to have numeric value, but keep in mind that these numeric values can have a lot of decimal spaces. So I would like them to limit to maybe 1 decimal space. You do that using a round function from base R. And then within that function, you specify here that you want just 1 decimal space. So this is how it's done. And then we close this, so we're done with aesthetics. We can now just simply define some of the constant values. And one of the constant values, for example, is the position of these labels inside of the bar plots. So we want them to be centered, both in terms of their vertical and horizontal adjustment. For the vertical one, you need to use position_stack. and define readjust here as 0.5 if you want it to be in the middle. And then outside of this, you can also define horizontal justification as 0.5. This will make sure that the labels are in the middle of the bar plot, looking from the vertical or horizontal landscape. Then you can also specify the size of your fonts. So I think from my experience working with these bar plots and annotating them, somewhere around the 3 size works really good. So I'm going to go for a bit lower, let's say 2.75, just to make sure that these annotations fit within the bar plots once we plot this. You can also specify the color, and this is the whole thing why we did this practice. So as we said here, higher values, we would like to have a contrasting, lighter text color. So that's going to be, for example, white. And finally, we can also customize this even further by creating bold fonts, so that it's even more visible. Now that we have achieved this, another thing that is very important here is applying this to those lower values that have lighter colors. So we're just going to copy this and paste, and then just change a few things. One of them is the condition. We want values lower than 4, for example. Then here, this is going to be the same as well, the horizontal justification size, except for the color, which I would like to be more like a charcoal gray. All right. Now that we are done with this, we can go even further with customization and customize the color. Since we are again using the discrete column from the table for our colors, we need to use the scale fill manual argument. And again, here we can specify the legend, because we're not going to have the legend for this bar plots because we already plotted one for the map. We're just going to leave this legend title empty. For the color values, we're going to use calls as we did before. So that's one of the things that you can do. Another thing that you can also specify within labs, for example, do you want a title? In our case, we are not going to go for the title, nor we are going to go for any caption. So that's also going to be empty. We're also going to omit any kind of X or Y titles. When I say X or Y titles, I mean X axis or Y axis titles. Then we can also customize as a final step the theme. So I like to use theme void once more to kind of get rid of then any kind of access features, such as, for example, those graticules. And then within the theme itself, I would like to specify some additional things. So one of them is, for example, we don't need a legend here. So legend position equals none. That's one. And then there is another one, which is for those country labels, I would like to give them a bit more space. And I would like also to change the font's size and the font color of these. Now, because these are on the y-axis, we need to use axis.text.y. And because we're dealing with text here, we need to specify element text. Now here, to assign more space, as you know from before, we can use margin arguments. And margin argument goes along with units, and then within the units, you need to specify the list of the things. Because it's on the y-axis, I would like to give more space on the top, while keeping everything else constant at the null. Finally, I would like to declare millimeters to be the main unit here, although it's not that much important, I would say. The next thing I would like to customize here is, for example, the color. So I would like them to be more kind of a charcoal gray. And also I would like to kind of decrease a bit the size so it doesn't, get over the bar plots or anything like that. So I'm going to set to 8. And finally, I would like all these, labels, country labels, to be a bit closer to the bar plots. So that's why I'm going to use this horizontal justification, and I'm going to set horizontal justification to 1. All right. Now that we have defined this, the one last step is to actually deal with the axes themselves. So you remember currently the way it's organized is we have countries on the x-axis, and then we have values on the y-axis, which means that we have bar plot spikes. What I think would be a more effective for our case is if we change the axis in such a way that they are horizontally aligned. So in other words, that country labels come to the y-axis and values come to the x-axis, just as we defined here that we want to customize that text on the y-axis. Now, instead of going back to that main aesthetics in ggplots and changing that, there is a very convenient function that exists in the ggplot itself. It's called chord flip, which will allow us then to actually flip those axes. All right, so this would be the code for the bar plots. And once we are now ready, we can just simply also print, and we can run all of this and see whether we are happy with the result. And if we are happy, then we can go forward and combine the bar plot and the map into a single plot. And here it is, the bar plots as we anticipated. It starts off with the countries with the highest value, which is actually Moldova, and then it goes down to other countries. So as you can see, we also apply the different coloring scheme. For those that have values higher than 4, they're in white, and for those values that are lower than 4, they're simply in charcoal gray. And yeah, I'm actually pretty happy with this outcome and with the outlook of this bar plot. So the next step will be to put together this bar plot and the map into a single plot. And we are ready for the final step, which is putting together the bar plot and the map into a single plot. For that purpose, we will be using the grid package from R, which allows us to create and put together things and increase the space for either one or the other item. So let's create another function, which is going to be called create instant graph map. And this is within this function is where we are going to do what we need. So we're going to create an object called VP, which is going to be a shorthand for a viewport. In other words, using grids package, we're going to create a viewport of a certain size. Then we are going to print both objects, both bar plot and map, and then this will put them into a single plot. But to do that, you first need to create some kind of a, as it says here, viewport. In other words, a landscape where you will plug in these different objects that you have. So this is how grid viewport works. The first thing you need to define is the width and the height of this viewport. So here we are talking about values from 0 to 1. So for our width and heights, this is really hit and miss, this part. So you really need to kind of try a lot. I already tried this, so what I'm presenting here is already something that is a solution. But oftentimes, if you have some kind of different objects of different sizes, other continents, or maybe different sizes of your charts, you will need to play a bit more with this one. So here, in short, we want a viewport that is higher than it's wider. So for the width then, we'll go for something like 0.5, and for the height, something that is closer to 1, so way bigger, way higher. So something like 0.85. It's 1. Now the second thing is, within this viewport, you want to specify the center of the viewport, so where things are going to happen. All right, and this is handled by x and y arguments. Again, we're talking about values which are from 0 to 1, and they relate to the place where the bar plot is going to be plugged in within that existing map. So as we said, we want a bar plot to be closer to the left-hand side. So if the left starts with a 0 and then ends on the right-hand side with 1, we will want something that is closer to 0, something like let's say 25. So occupying basically everything from the first quarter to everything until the middle of the plot. And then in terms of the y-axis, this means, okay, where actually this bar plot is going to be positioned, like how high, but keeping in mind also the height of this, of this plot. So the y-axis should be bigger than or greater than the x-axis, And I would for now put it somewhere in the middle. So let's say 0.5. Again, this all is a bit of a hit and miss, and it requires a lot of testing. Now that we define this grid viewport, we can go on and save this graph. Now, the best way to do that is not to use the actual ggSave. Rather, it's good to use the PNG one, which is going to export your map as the PNG image. So the first thing we need to specify here is the name. So let's say infant mortality rates 2021.png. So that's the first thing. Then the second thing we want to specify are the actual dimensions of this image. So height and width, and they should be in pixels. So let's go for something like 4000 by 4000, so very crisp image. And the final thing that we can specify is the resolution of this PNG file. And I'm gonna again keep it at very high, so let's say 600 resolution, 600 pixels. All right, so now that we have defined what we want to save, how we want to do everything, next thing is to actually print those objects and put them within that viewport that we just created. So then we're going to use grid again, and then we are going to create a new page. So grid.newPage. And then once we do that, we print first the map, and then we print the box or the bar plots. When we print the bar plots, what we actually need to say is, we need to say that bar plot is gonna be nested based on that special grid that we created. So we're gonna say that the viewport equals to VP. So VP equals VP. And then once we are done with all this printing, for us to kind of execute this PNG, we need to say dev.off. And this is how you do it. All right. And then at the end, you can just simply say return, where you're going to return, this whole thing that we just defined. And then in order for this to be saved, you only need to call this function with the closed brackets. And once you run this, we can then finally inspect the file that we got. And here it is, the final map where we combined the bar plot and the map, and it seems it went well because neither the bar plot or the map are overlapping each other. I really like how bar plot is positioned here just next to Iceland, but it's not overlapping it, basically occupying every possible space that we have here on this plot. You can also see that the title is visible as well as the legends, so it's really clear what we are conveying here. You can also see that the numbers on the bar plot indicating infant mortality rate values are also visible along with country names. Next thing is, of course, that you could do try and apply this to other continents, which I think is going to be way easier than Europe, because for Europe we had to create a bounding box and play a bit with it. But for other continents is pretty straightforward because you don't need to do that. You can simply then use this template and play with this viewport and see how you can put together different chart types and maps. All right, that's all for today, folks. In today's tutorial, you learned how to create Inset graphs within a map, and all that using the Global Health Observatory data, which we access through API using a dedicated library in R. What you can do next is definitely use some of other data, for example, the World Bank data that we covered before, and try to make an Inset graph map with the help of R and ggplot2 and grid package as well. But if you would like to replicate this analysis, I prepare a code in a GitHub repo in the description below. So feel free to clone this repo, reuse it, modify it as you see fit. Also, if you have any comments or questions or feedback, you can write to me here on YouTube, but also on Instagram and Twitter. If you're new to R or you would like to expand your GIS and data visualization skills with R, I prepared a few tutorials for you, so go out and check out them. See you next time.